Grade 11s, welcome to another series of iCampSA lessons. So today we'll be covering the sine rule proof, right? So the basic rule or the standard rule of sine rule says that sine of angle A over side A, so this represents side A, is equals to the sine of angle B over the side B equals to the side of angle C over side C. Remember, in a triangle, we have three sides. So the sides A, B, C will represent the three sides that we find in a triangle. The same applies with angles. In a triangle, you can only have a maximum of 3 angles unless you construct other lines, but in a basic triangle, you will only have 3 angles. So this will be your angle A, angle B, angle C. So this is what the rule says, right? And the inverse is true. So this is when if you see anything like A, now if the numerator becomes the denominator, which is A sine of angle A equals to B of sine angle B is equals to the sine of, C over your sine of angle C. Right, so the inverse is true. So this is literally the same thing, right? So these two things are literally the same thing. So now let's go ahead and try to see how we can solve or we can prove that. But before we go into that, I want to take you to take note of your trigonometric ratios, right, which are very important, right? I want you to take note of your trigonometric ratios, which is your sine theta, your cos of theta, and then your tangent of theta, right? So remember that these are applicable, right? It's very important that you note that these are applicable in a right angle triangle, right? So these trigonometric ratios are applicable in a right angle triangle. So we must always remember that so that we don't make mistakes, because I've seen students making mistakes applying the trigonometric ratios, especially when you don't have a right angle triangle, right? So this is what we are going to need in order for us to try and do that, right? And then another thing is in terms of the sine rule, right? In terms of the sine rule, we have a sine rule for acute-angled triangles, and we also have a sine rule for obtuse-angled triangles, right? So both are equally important because you need to know them. Depending on what the examiner says, you should be able to answer for both scenarios. So the first one is when I have, right? So the first one, I can just say A, which is going to be your acute-angled triangle, right? This is still sine rule. And then the second one, this is A, and then the second one is obtuse-angled triangle. Great. So what I'm going to try and do, I'm going to try to start by this one, right? This is the one that I'm going to start with. I'm going to start with the sine rule for acute-angled triangle, right? Great. So this, I'm going to call it 2. So it's for acute-angled triangle sine rule proof, right? We are still doing your sine rule, right? So we are proving it, right? So let's draw the right angle triangle that we are talking about. So this is a triangle. It will look like this, right? So what this means that all the angles in this triangle are less than 90 degrees, as you may have done in grade, I think grade 9 maths when you do your angles and what they mean, right? So we are going to call this point A, right? It's going to be A, B, C, right? So before we go into anything, right, you have point A, point B, point C, which makes this triangle ABC. So the way we name triangles in when we solve this, right? So the way we name sides, it should be relative to angles, right? So for example, right, this side, I'm going to call it, so this entire side, because it's opposite to this point, this is going to be side A, right? And then this is going to be what? It's going to be side B. And then this is going to be what? It's going to be side C. Right. So this is how we name the triangles, the sides. So this is going to be side A, right? And then this is going to be side B. And then this is going to be side C, right? So now I have sides, and then I can call this angle A, angle B. This is going to be angle B, angle C, angle A. So now I have my right angled triangle, and now I'm fine, right? Now, in order for me to start proving this, right, I'm going to construct what is called a common height, right? So this is what I'm going to do. I'm going to construct what I will call a common height, right? So this will cut this triangle into two halves, right? And here it's going to form what? It's going to form a 90-degree angle. And then I'm going to call this height H, right? And then I can call this point D, right? This is going to be called point D. So now I have two triangles. This is my first triangle, right? This is my first triangle, and then this is going to be my second triangle, right? And I'm going to use both these triangles because they have something in common. I'm going to derive equations such that whatever is common is going to be the subject of the formula, and then I will equate and then see what I'm left with and see how I can go further into proving that, right? So I'm going to start with triangle 1. So that is triangle ABD, right? It's going to be triangle ABD. Great. So I'm going to say in triangle ABD, right? So this is when now I'm going to start applying my trig ratios, right? So in triangle ABD, so this is this triangle, or you can literally say or triangle 1, right? Which is literally the same thing. So now what I'm going to do, remember it's a sine rule, so I'm going to use sine trigonometric ratio. So I'm going to say sine of this angle, right? So this is going to be sine of angle B, right? So now I'm going to say sine of angle B, right? It's going to be equals to, remember from sine, so it's going to be opposite over hypotenuse. So what is my opposite side? My opposite side is H, right? Which is my height. And then what is my hypotenuse? My hypotenuse is C, right? So now remember I said H is common in both these triangles. So I'm going to try and make H the subject of the formula. And the way I'm going to do that is multiply by C, right? And then now I have this and that cancel, right? And then now I'll be left with H is equals to C sine angle B, right? And then I'll call this equation 1, right? So now I'm going to apply the same thing, but now I'm going to do it on triangle 2, right? So I'm going to say in triangle ADC, right? In triangle ADC, so now this is the angle that I'm going to be dealing with. So now I'm going to say sine of angle C, right? It's going to be sine of angle C, which is going to be equals to the same thing, opposite over hypotenuse, So your opposite side is going to be your h, and then your hypotenuse is going to be b. Now I multiply by b both sides, multiply by b both sides, and then I'll be left with h equals to your b sine of angle c, right? So it's not clear here. I'm just gonna write this on the other side, right? So this and that will cancel, right? And then now I'll be left with h is equals to b sine c, b sine c. Great. And then I'm going to call this equation 2, right? And then from there I'm going to substitute equation 1 into equation 2. Why? Because they have something in common. They have h as the common factor, right? So h and h here is common. So equation 1 is going to be c sine b, right? It's going to be c sine b equals to, and then my equation 2 is going to be b sine c, right? And then now what I'm going to do is, remember what I want, right? What I want is I want to have sine a over a, or sine b over b, or sine c over b, right? So in order for me to have that, here I'm going to divide here by bc. I'm also going to divide by bc here, right? I'm going to divide by bc. So if I do that, it means that this and that will cancel, this and that will cancel, and then I'm gonna have sine of angle b over b, right? Sine of angle b over b equals to your sine of angle c over c, right? So now I have proven it, right? I've proven the first rule for acute angle triangles. So this is also going to be true for sine of angle a over a. It's also going to be true for that, right? So now let's go and look at how we can do that for acute angle triangle. No, for obtuse-angled triangle. Okay, so now for obtuse-angled triangle, right? This is the proof for obtuse-angled triangle. Right, so most of the time they won't ask you to prove for acute angle triangle or obtuse-angled triangle. You will be given a triangle and you should be able to look at the triangle and detect if it's an obtuse-angled triangle or it's an acute-angled triangle, right? So now let's draw the triangle. So this is usually how the triangle will look like. Wait. Great. So now let's say this is angle A. This is angle A, B, and then this is C. I think my pen may have reduced in size, right? So just want it to be clear. Great. A, you can just call this B, C, and A. Right. Now, remember how we said we name the sides when we do this thing. So this side, because it's opposite here, so this is going to be your A, right? And then this is going to be your B, and then this is going to be your C, right? So this, you don't have to cram doing it this way. However way you want to do it, right? Just make sure that your side corresponds with your angle, right? So if this was side A, I mean, if here you had A, right, this would have been angle, I mean side A, right? If this was angle A, this would have been what? Side A, right? So you don't have to cram it and do it the way that I do it. However, you are given the triangle, you should be able to name your sides and subsequent to that, name your angle, right? Great. So now remember what I told you, right? That you are going to need trigonometric ratios in doing all this, right? But when you look at this triangle as it stands, I don't have any right angle triangle, right? Which means that I have to construct a right angle triangle in order for me to be able to apply my trigonometric ratios, right? And in order for me to do that, or the way I can do that, is I have to construct, right? I have to construct a line that will make this triangle be a right angle triangle, and that is going to be this one, right? I'm going to construct a line from here. Let me just take my B here. Let me just take my B here, right? So now I'm going to construct a line, right? And then this is going to be 90 degrees. Let's just make it neat, right? And then this is going to be 90 degrees. And then now this is D, right? And then H. Great. So now I have two right angled triangles, right? So this is going to be the first one, right? This is going to be the first one. And then the other one, it's going to be this one. So if I have two right angled triangles and I have something in common between those triangles, which is side H, right? It means that I can derive my trigonometric ratios in terms of H and then substitute or equate H, right? So let's go ahead and see how we can best do that. Oh, may have forgotten something, right? So if this is angle C, we did not forget, right? If this is angle C, right? This is angle C. This angle here, it's going to be 180 minus C. Right, so if this is angle C, right, if this is angle C, that means that this angle is going to be 180 minus C. And the reason why I say that, it's because of angles, right, on a straight line. So this is going to be 180 minus C. Great. So now I'm going to go ahead and try to solve. Oh no. I just wanted to move this B to here. Great. So now I'm gonna go ahead and try to solve. So I'm gonna start with this triangle, right? I'm gonna start with this triangle. Great. So I'm going to say in triangle ACD, right? So in triangle ACD, right? In triangle ACD, right? Now I'm going to have my sine, right? This is the angle that I'm going to use, right? It's going to be your sine of 180 minus C. This is minus angle C, right? Is going to be equals to, what is the opposite side? Sine is opposite over hypotenuse. It's going to be H over B, right? Now, what I'm going to do is I'm going to multiply by B both sides. Multiply by B, multiply by B, right? And then now, this and that will cancel, And then now I will have H is equals to B sine 180 minus C minus angle C, right? Remember, this is 180 degrees. It should be 180 degrees, 180 degrees. Remember your reduction formulas, right? Sine of 180 minus x, or 180 minus theta, or 180 minus any angle, it's going to be the sine of that angle from your reduction formulas, right? So it means that I'm going to have H is B sine of angle C. Great. So now I have this, right? And I'm going to call it equation 1. Right, so now I need another equation, and what I'm going to focus on now, the triangle that I'm going to focus on is going to be this big triangle, right? It's going to be this big triangle, right? So I'm going to take this to the other side, and we try and solve that. Right, so now I'm focusing on the big triangle, right? Now I'm focusing on the big triangle, right? So this is the angle that I'm going to focus on. So the big triangle is going to be it's going to be in a triangle ABC, right? In triangle AB, no, it should be ABD, right? So the sine of angle, which is going to be a sine of angle B, the sine of angle B is going to be equals to, what is opposite? Your opposite is going to be H, and then what is your hypotenuse is going to be C. So I can multiply by C both sides, multiply by C both sides, and then this and that will cancel. Now I'll be left with H is equals to C times sine of angle B, right? And this is my second equation, right? So this is my second equation. So from here I can just substitute 1 into 2, right? So what is my equation 1 saying? It's B sine C. So I'm going to have B sine of angle C is equals to C sine of angle B, right? And then from here, both sides, I'm going to divide by BC, right? So B and B will cancel, then C and C will cancel. And then from there, I'm going to have sine of angle C over C is equals to your sine of angle B over B, right? So now I have proven the sine rule, right? Now I have proven the sine rule. So great. So yeah, this is how we prove your sine rule. Quite simple, usually 4 marks if I'm not mistaken. But you should not have problems when you are doing this. The most important thing is to remember that in order for you to do any proofs, right, you would need to apply your trigonometric ratios. And in order for us to do that, you need your right angle triangle. So if you don't see any right angle triangle, construct a line such that it will make the triangle have a right angle triangle. Then go ahead to apply your trigonometric ratios. Great. So now we're going to move on to other proofs, which should be your cosine rule and area rule proofs. See you on another video. Thank you.